Okay, so we're going to be looking at our other 4 trig functions in a little more detail today. We looked in depth at sine and cosine. If you'll remember, we've already defined sine of an angle to just be equal to the y value on the unit circle. We said, and then we also talked about how cosine of an angle is equal to the x value on the unit circle. And that really only came into play when we were rotating onto one of the axes, right? Because axis is not a word. But that's really the only time I use that. Well, right here we have the same definition for tangent of an angle, cotangent of an angle, secant of an angle, and cosecant of an angle. So you can see tangent is equal to y over x. Cotangent is x over y. Secant is 1 over x. Cosecant is 1 over y. Now, just to be real honest, I don't have any of that memorized. Now, if I did, it would probably make some of my problems a little bit shorter, especially when I rotate to one of the angles. But this here is the way I remember them. Okay? Identities from the definitions. If alpha is any angle or real number, we could say tangent of the angle is equal to sine over cosine. So again, we said sine was just the y value, cosine was just the x value. So tangent being sine over cosine really matches up with tangent being y over x from right here. And then cotangent is just the reciprocal of tangent. So if tangent is sine over cosine, cotangent is cosine over sine. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So we kind of already talked about that a little bit when we were given a rotation and we were asked to find the 6 trig functions. So what we're going to be doing today, and then what you're going to be working on tomorrow, is really working on these 4 trig functions evaluated at our angles that are on the unit circle, so our special right triangles. Okay, so these 2 ask us to find all 6 trig functions, which again is similar to what we've been doing. So this is just kind of an intro into it. If you'll remember, our quadrants, all of them are positive. Students, so only sine and its reciprocal are positive. Take, only tangent and its reciprocal are positive. And then calculus, only cosine and its reciprocal are positive. So that's all this is reminding us of over here. Okay, so the first one tells me to identify all of them at pi over 4. So maybe you've got it memorized by now, maybe not. If you do, you know pi over 4 is the same thing as 45 degrees. If you don't, you're going to have to do a conversion. So you could say pi over 4 times pi over 180. Right? And that would get you 45 degrees. That looks a lot like 450, so I'm going to fix that. Okay, so now I'm going to find all 6 trig functions evaluated at 45 degrees. So I'm looking for sine of pi over 4. Cosine of pi over 4, tangent of pi over 4. Okay, then I go, the reciprocal of sine is cosecant. So I'm looking at cosecant of pi over 4. The reciprocal of cosine is secant. So that's secant of pi over 4. And the reciprocal of tangent is cotangent of pi over 4. Okay, so I'm going to go ahead and draw out my special right triangle. Because it's a 45-degree rotation, I'm in the first quadrant. That puts me here. When I rotate 45 degrees, my central angle is 45 degrees, which means I have radical 2, and 2 as my sides. Now, because I'm in the first quadrant, everything is positive. Sine is the opposite over the hypotenuse, so that's going to give me radical 2 over 2. Cosine is the adjacent over the hypotenuse, so it's also going to be radical 2 over 2. Tangent of pi over 4, that's going to be the opposite over the adjacent. So that's radical 2 over radical 2, which simplifies to just give me 1. And now when I find the other ones, I always just find them by their reciprocal. So you could go through and memorize the y over x stuff, but I always just find sine and then I find its reciprocal. So the reciprocal of this means I'm flipping it. So that's going to be 2 over radical 2, which I can't have. I think if you put that in your calculator, it will simplify that for us, rationalize it. But that's going to be 2 radical 2 over 2, which is just radical 2. Secant is going to be similar. Right when I flip 2 over radical 2 and then simplify that out, it's going to give me radical 2. And then the reciprocal of 1 is also 1. So cotangent of pi over 4 is 1. Okay, the second one's 150-degree rotation. So again, I'm going to go ahead and line it all up. I'm going to find sine of 150, cosine of 150, tangent of 150. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. Now I'm going to draw my triangle. 150 degrees puts me in the second quadrant. That puts me here. And if I rotate it 150 degrees, then that means this part was 90, and this part had to be 60 to get me to 150, which means my central angle has to be a 30-degree angle. So this is a 30, 60, 90. Across from the 30 is 1, across from the 60 is radical 3, and the hypotenuse is 2. Now, because I'm in the second quadrant, only sine and its reciprocal is positive, which means all the other ones are going to be negative. So I could go ahead and put a negative there just so I don't forget it. Now, when I'm looking at sine, sine is the opposite over the hypotenuse. So that's going to give me 1/2. Cosine is the adjacent over the hypotenuse, so that's going to be radical 3 over 2. Tangent is the opposite over the adjacent, so that's going to be negative 1 over radical 3. And then again, if you put that in your calculator, it should rationalize it for you to negative radical 3 over 3. And I'm going to find the reciprocals. So the reciprocal of 1/2 is 2. Okay, the next one, the reciprocal of negative radical 3 over 2 would be negative 2 over radical 3. Again, I can't have a radical in the denominator, so we could rationalize that. That's going to be negative 2 radical 3 all over 3. Should be my answer for secant. And then when I flip tangent to find cotangent, I could flip this one, but I would have to go through the trouble of rationalizing it. So I'm just going to flip this one. 1 over radical 3 becomes radical 3 over 1, which is just negative radical 3. Okay, so I'm looking at this one. It tells me to find the exact value of tangent of 0. So this is one of my special cases where I rotate onto an axis. So I've rotated nowhere. This point is the point 1, 0. So this is not on your notes. I'm doing this freelance. I don't think your notes have enough questions for you. I realize everybody's flipping. Okay. So right here, if I was asked to find tangent of 0, we could know that tangent is y over x. Or I know tangent is sine over cosine. And then I know that sine is the y, cosine is the x. I have to do one more step just because I don't have this memorized. I should, but I don't. But this is basically the same thing that I'm using here. So when I plug that in, at that point, the y value is 0, the x value is 1. 0 over 1 simplifies to give me 0. So tangent of 0 is 0. It asks me to find the exact value of cotangent of pi over 6. So again, from our notes, we could know cotangent is the x over the y, or it's cosine over sine. In my head, though, when I think of this, I know it's the reciprocal of tangent. So the way that I think about this, pi over 6, I know that's a 30-degree rotation. If you don't know that, you need to convert it, and you would get 30. So because I'm rotating 30 degrees, that puts me in the first quadrant. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. So I know tangent of this angle is equal to the opposite over the adjacent. So then I would say, well, cotangent of this angle would be the adjacent over the opposite, which is just radical 3. So my answer here to find the exact value of cotangent of pi over 6, it would be positive radical 3. Okay, here I'm asked to find cotangent of 2 pi over 3. So same idea. I know 2 pi over 3 is 120 degrees. If you don't, you're going to have to convert it. So a 120 degree rotation puts me in the second quadrant. 120 degrees, this is 90, which means this little section is 30, which means my central angle here is a 60-degree angle. So it's a 30, 60, 90. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is a 2. I'll do that in a different color. Okay, now I'm in the second quadrant. So sine is the only thing positive. So when I think about finding tangent of 2 pi over 3, I know it's going to be negative. Tangent is the opposite over the adjacent, which means cotangent is going to be the reciprocal of that, the adjacent over the opposite. And then when I rationalize this, that's going to be negative radical 3 over 3. So my answer for cotangent of 2 pi over 3 is negative radical 3 over 3. Okay, this one tells me to find the exact value of secant of pi. Okay, so I know pi is 180 degrees. So that's going to put me here on the negative x-axis. So I know I'm going to have to use my special cases. So I'm going to write down what that ordered pair is. So because I went left 1, that's negative 1. Up or down, nowhere. So it's 0. Now again, the way I think about it, I know secant would be the reciprocal of cosine. I know that cosine of an angle is equal to the x value. See, I mean, I really got to think. I get it mixed up. Now, because it's the x value, in this, the x value is negative 1. So I would say cosine is negative 1. And the reciprocal of cosine is secant. So I would do the reciprocal of negative 1. So if I flip negative 1, it's still negative 1. So secant of pi is negative 1. Okay, so here I'm told to find cosecant of negative pi. So now because my angle is negative, I'm rotating in the negative direction. So I'm going clockwise. This would be, I know pi is 180 degrees, so negative pi is going to be a negative 180 degree rotation, which puts me here. So because I rotated to an axis, I need to know what these coordinates are. So this is the point negative 1, 0. So my coordinates here are negative 1, 0. Now, in my head, cosecant is the reciprocal of sine. So I'm going to find sine of the angle. I know sine is equal to the y value. Therefore, sine of negative pi is going to be whatever the y value is here. So my y value is 0. So now when I'm looking for cosecant, cosecant is going to be the reciprocal of 0. So if I flip 0, I get 1 over 0, which is not a number. So cosecant of negative pi is undefined. So we can have, with sine and cosine, if you'll think about their graphs are continuous. There's never any gaps, any spaces. But remember, when we divide by 0, we get that error. And when we graph those in 112, that's where we got those asymptotes. So what this is leading us into is we're going to shortly start graphing cosecant, secant, cotangent, and tangent. They all have asymptotes. So this is kind of the lead up into what those are going to look like. I said what they're going to look like. I meant thinking about their features. That you can't tell anything what it looks like from this. That's a dumb way to state it. Okay, so the first one here tells us to find secant of 20 degrees. So make sure your calculator's in degree mode first. You're going to have to go back and forth between degrees and radians. Or you're going to have to go through converting, which nobody wants to do. And now to find secant of 20 degrees, we're just going to put in secant. Everybody see their secant button? Oh, okay, we didn't have one. Okay, so we can't just put in secant because we don't have a secant. So we have to use our properties that we know about these. So we know secant is the reciprocal of cosine. So what we can do is we can say secant of 20 degrees is the same thing as 1 over cosine of 20 degrees. Just the reciprocal. Now you put this in your calculator. 1 over cosine of 20 degrees. And when you do that, you get 1.04. Is that it? There'll probably be 4 decimal places, I'm going to guess. Let me look at your homework. Round to 4 decimal places. So 1.04. 0.64. 2? I'll take your word for it. Okay, next one, cotangent of pi over 12. So is this in degrees? How do you know? Because there's no degree sign. So because this one is in radians, we're going back to radians in our calculator. We're looking for cotangent of pi over 12. So I know cotangent is the reciprocal of tangent. So I'm going to put 1 over tangent of pi over 12 in my calculator. And this one's going to be a little bit prettier, I think, right? What'd you get as an answer? You got what? 2 plus radical 3. Okay, now, depending on the questions, if it says give an exact answer, this is the exact answer. Sometimes it may tell you to round to 4 decimal places. Well, if it does that, you'll just click your S to D button, right? And then give the 4 to 4 decimal places. Either one. Okay, and then C part. Okay, is this in degrees or radians? Is that degrees or radians? There's no degree sign. So what is it? It's not degrees, it's radians. Yes, correct. If it's going to be in degrees, you have to see the degree sign. So even though this doesn't have pi, it's still a radian measure. Radians don't always have to have pi. So we make sure we're still in radians. I know that cosecant of negative 12.4 is going to be equal to 1 over sine of negative 12.4. And then when I put that in my calculator, I get, what'd you get?
6.0385.
Beautiful.